Hi guys, Mrs. Snowden here, talking about some trig notes for 1-4. Last time, when in section 1.3, talked about definition 1 of the 6 trig functions in standard position. So in terms of x, y's, and r's, sine was y over r, and then its reciprocal cosecant was r over y. And then cosine was x over r, and its reciprocal secant was r over x. And tangent was y over x, and then its reciprocal cotangent was x over y. So using that fact, we have some reciprocal identities. So cosecant is 1 over sine, and I wrote it down there already, or sine is 1 over cosecant. That means that if sine of theta is 3/5, then cosecant of theta is 5/3. We can just flip it over. They're reciprocals. And if secant of theta is 1 over cosine, that means cosine of theta is 1 over secant. So if cosine is negative root 3 over 2, secant then is negative 2 over root 3. And we don't leave radicals in the denominator, so let's rationalize that guy. And I get negative 2 root 3 over 3. Cotangent. Its reciprocal is tangent, so cotangent is 1 over tangent, or tangent is 1 over cotangent. So if tangent of theta is 2, then cotangent of theta is 1/2. These ones you should put into your memory banks, okay? So these are your 6 reciprocal identities. We're going to use them a ton. We're going to use them in the next section. But your reciprocal identities, you need to put in your memory banks. Pre-calc's going to expect you to know them. Okay, so we're going to say, what's the reciprocal of cosecant? And you're going to say 1 over sine. What's the reciprocal of cosecant? Secant, 1 over cosine, that sort of thing. So that's the first of our identities. Today we're going to talk about putting everything in your memory banks, and we just need to memorize these. The next section talks about ratio identities. So in terms of ratio identities, the tangent is the sine of theta over the cosine of theta. Now, that's the part we need to memorize, and the next part I'm going to show you why that works. What do you remember about sine in terms of x, y's, and r's? Well, sine is y over r, and cosine is x over r. Well, they both have the same denominator. That means that they will cancel. So I'm left with y over x. And what do you know about y over x in terms of our trig functions? It's tangent. So this is the part you need to memorize here. This is the proof that shows why that works. Okay, well, if tangent is sine over cosine, some of you can probably guess then that cotangent is cosine over sine. And again, I'm going to show you why that works. Cosine, in terms of x, y's, and r's, is x over r. Sine is y over r. The r's cancel, so I'm left with y over x. And just like we talked about last time, or Mr. Smith talked about last time, that's cotangent. So, our ratio identities. Tangent is sine over cosine. Cotangent is cosine over sine. Now, that's really useful if we have sine and cosine and we want to just find tangent and cotangent. Okay, so here, for example, it says if sine of theta is negative 3/5 and cosine of theta is positive 4/5, find tangent and cotangent. All right, well, tangent is sine over cosine. So sine is negative 3/5 over 4/5. They both have the same denominator, so that's going to cancel. So I'm left with negative 3/4. Cotangent. 2 ways to get that. We know that tangent and cotangent are reciprocals, so I can just flip that guy over. Or I could do cosine over sine. You're going to get the same thing. I'm going to use the fact that they're reciprocals, and it's just negative 4/3. Now, how do I keep those guys straight? I know that this cotangent starts with cosine starts with so it's on top. That's how I remember that. And the sine will be on the bottom. Tangent doesn't start with that so cosine has to go on the bottom. That's how I remember it. Up here at the top, I probably should mention how I memorized that too. Tangent and cotangent aren't too bad. Those seem to make sense. But sine starts with an S. Its reciprocal starts with a C. Cosine starts with a C. Its reciprocal starts with an S. So that kind of helps me remember, okay, I've got to flip there. All right, so back down to this guy. Cotangent was -4/3. Tangent, -3/4. All right, special notation. Sine squared theta just means sine of theta squared. Okay, so instead of writing it with all the parentheses, it just means square the number that represents sine theta. So if sine of theta is 3/5, sine squared of theta is 3/5 squared. And we know if we square a fraction, we square the numerator to get 9, we square the denominator to get 25. All right, Pythagorean identities. At the bottom of your paper, there in that little chunk right there, there are 3 Pythagorean identities. Okay? The Pythagorean identities are right here. Again, anything that I've put in a box today, put in your memory banks. Okay, so the first Pythagorean identity is cosine squared plus sine squared equals 1. Now, the 2 below it are just a rearrangement of that. Okay? So, if I subtract cosine to the other side, I get 1 minus sine squared. And then if I take the square root, that's where this first one comes from. Same thing here. Again, so if I take and I subtract sine squared, I would have cosine squared theta equals 1 minus sine squared. And then if I take the square root, I get that guy. Okay? Same thing. However, if I subtract the cosine squared over, so I get 1 minus cosine squared, and then I take the square root. Remember, I'm the one taking the square root. That's where the plus or the minuses come from. Right now, let's talk about where those Pythagorean identities come from. So let's ignore those 2 right now, but let's just talk about sine squared plus cosine squared equals 1. This over here shows us where that comes from. X squared plus y squared equals r squared. What do you know about that? That is the formula for a circle, right? X squared plus y squared equals r squared. What if I divide everybody by r squared? All right, well, if I divide everybody by r squared, I get x squared over r squared, y squared over r squared equals 1. X over r, the whole quantity squared, plus y over r, the whole quantity squared, is equal to 1. And in terms of x, y's, and r's from last time, that's these guys right here. So x over r is cosine squared, y over r is sine squared. So here's my Pythagorean identity. So that's where that comes from. Now, if I were to, instead of dividing by r squared, and I divide by x squared, that's where I get this guy right here. So 1 plus tangent squared theta equals secant squared theta. 1 plus cotangent squared theta is cosecant squared theta. Now, these are pretty helpful if I have one. Trig function, they give me one trig function. It tells me which quadrant I'm in, and I can figure out who's positive and negative based upon that. So, using your identities is another way to find all 6 trig functions instead of using x, y's, and r's. You can still use x, y's, and r's. That's still a fine way to do it, but I'm going to show you how to do it with identities in this section. On your homework, find the method that works best for you. So if you're comfortable finding x, y's, and r's like you did in section 1.3, then continue to do that. Okay? All right, so first example right there, it says find if sine of theta is 3/5 and theta terminates in quadrant 2, find cosine and tangent. Okay, if it terminates in quadrant 2, let's talk about that for a second. All students take chemistry. All right, I'm in quadrant 2. Okay, quadrant 2. Who's positive? Sine and its reciprocal are positive. That means that cosine and tangent will both be negative. So I need to remember that as I'm solving these. Okay? All right, so cosine. I want to find cosine, so I'm going to use part A here for my Pythagorean identity. Cosine theta. I know I'm in quadrant 2, so that means cosine has to be negative. Okay, so I'm going to pick the negative version of my square root, and I'm going to do 1 minus sine squared. All right, so I have negative square root of 1 minus 9 over 25. Well, in order to subtract those guys, I need a common denominator. So I have the negative square root of 25 over 25 minus 9 over 25. 25 minus 9 is 16 over 25. So this guy is negative 4/5. So cosine is negative 4/5. Now I have cosine and I have sine, so I'm going to use my ratio identity to find tangent. Oop, can't see what I'm doing. Tangent is sine over cosine. Sine is 3/5. Cosine is negative 4/5. Again, they have the same denominator, so I get negative 3/4, which is good. That's what I wanted to get because we knew tangent had to be negative because I'm in quadrant 2. All right. Last one there. If cosine of theta is 1/2 and theta terminates in quadrant 4, I'm in quadrant 4, find all 6 trig functions. All right, well, if I'm in quadrant 4, I'm going to look at this guy right up here. Cosine and its reciprocal are the only 2 that are positive. Everybody else is going to be negative. Okay? If you miss the negative sign, it's wrong because we need to be in quadrant 4. Okay? All right, cosine. Again, I'm going to show you how to do it with the trig identity, the Pythagorean identity, and as soon as I get the Pythagorean identity to get sine, then I'm able to find all the rest. All right, so let's do sine. I'm in quadrant 4. I know sine is negative, so I'm going to do the negative square root of 1 minus 1/2 squared. The negative square root of 1 minus 1/4. 1 minus 1/4 is 3/4. So I have the negative square root of 3 over 4, which becomes negative root 3 over 2. I just separated the radical. All right, I have sine and I have cosine. I'm just going to make a little chart. So sine, we have negative root 3 over 2. Cosine, they gave us, is 1/2. Tangent, we can take sine and divide it by cosine. Negative root 3 over 2 over 1/2. So I get negative root 3. All right, now let's flip them. Cotangent. Let's flip that guy over. Negative 1 over root 3 and rationalize. Negative root 3 over 3. Secant. Flip 1/2 over. I get 2. Cosecant. Flip over. Negative 2 over root 3. I got to rationalize it. Negative 2 root 3 over 3. And there are the 6 trig functions based upon knowing I'm in quadrant 4 and I have 1 trig function. Okay, like I said, you can still do it in terms of x, y's, and r's, so you could have found x over r and then figured out what y was. using the Pythagorean theorem and that sort of thing. But there you go. There's the notes for 1-4.